So my name is Mike. I'm from the University of Central Lancashire, which sort of begs the question as to why I'm here, really. Why am I here at a 3D printing event? Well, first of all, it said free bar, and working at a university, that's always a very good sign. It's quite intimidating to be stood in front of a room full of artists, graphic designers, illustrators, because I actually work in manufacturing. If you just go back a couple of slides, right up to the lab. That's my lab. So I do a lot of work with robotics and vision systems and that sort of thing. And about 9 months ago, I got a delivery, which was just basically a cardboard box, and it said 3D printer. And I got told, figure out how this works. Fair enough. So what we've actually got, if you click on a slide, is the Up, which, like the rest of you, I'm quite jealous of the nice maker bot that's sat in the corner, because it's a very fancy version of what I've got. I end up printing on a little perforated board, and we work at about 170 degrees, 270 degrees, and we work in one colour. If you click on, there's a few examples of stuff from my lab. And what I actually produce mainly is brackets and grippers and pieces that look like this. So we do a lot of interaction with pistons and those sort of elements. So I produce robust, hard-wearing things rather than nice little artistic things. So, sorry, that's a little bit administrative. I got asked to talk tonight, so over the last couple of days I've actually got to print out some toys and some quite nice things, none of which are my designs. I've grabbed them all from Thingiverse and other libraries that are available. And you click on one more. I decided to print one of those, which is a minion. I thought I could use one at work. Turns out I can't, but I thought I'd try. So what you're going to get, looking at the guys that have gone before you, the prints that they've done have actually been done in a different method. They've been done through laser sintering. What you guys are going to get is basically extruded plastic. So it's plastic that comes out of a nozzle, and any open parts, so arms, legs, noses, ears, goggles, they're all going to have support material in, which looks like that. Okay? So that is what you're going to get, and it's knocking around somewhere. And this support material is quite easy to remove, but it's what you're going to get back when you get your print. So what I'm going to do is I'm going to pass this round. Feel free to try and break the support material off, just so you know what you're going to get. Okay? Apologies to the cleaning staff, because there'll be quite a lot of yellow bits floating around afterwards. So feel free to have a play with that. That's your first stage. Okay? So you're going to have to peel around and pull the support material off the model. That's something that's worth thinking about when you're designing your model. Okay? The wider the reach, the longer the arms, the more support material you're going to have to take out. And where each bit of support material joins, there's obviously a little bit of sanding or filing or finishing that you have to do. So when you've actually taken the support material off, you'll end up with something that looks like that. Basically a single coloured plastic blob, if you've got it right. Okay? I'm guessing that the guys that are doing the printing will sort the orientation out and things like that, so that should be what you end up with. From there, there's different methods of finishing. This is what has now become known in the office as the torture chamber. It's a very large glass jar with nail varnish remover in the bottom, and it's an experiment that I've still not got right. But basically, you boil the nail varnish remover, and it polishes the top surfaces of the model. So you end up with a mirrored finish piece that looks like that. Looks pretty good if you get it right. If you get it horribly wrong, what you end up with is a melted blob, and you will lose some of the definition of it. So the recommendation for what you can do, if you're not going to go down that route, is basically sand it. You get a top surface of about 6 or 7 layers, so you can sand it back. You can put an epoxy filler on it, which a lot of people do. So then you get a paintable surface. A lot of the wax models, you're saying that you get acrylics that you can paint with. You can go straight onto them. It's just like painting a plastic. Put a base coat on and paint over the top. Just as I say, considerations when you're doing your designs is to look at the shapes that you're producing, where your support materials are going to form, so anything that overhangs is going to have support, and go from there. Be inventive with it. Most of them will be printed stood up, so you'll see feet, you'll see bits and pieces in there, and then, thank you, somebody's actually started to take the support material off. And what you'll end up with is something that's usable and paintable and workable once you've got to that stage. The other considerations that you might want to bring in, 3D printing works in layers, so you can actually produce movable parts. There's loads of bits on the table here, there's some chainmail, there's some bearings, so your 3D characters can actually take on a new dimension. They're not a static model. If it's got chainmail armour, make it movable chainmail armour. Give it something that a 2D sculpted model doesn't have. Give it some flexibility, give it some movement. Paint it, play with it, experiment. The machine will do the rest. The machine will put the supports in. Just consider it when you're taking it out afterwards.